Hello everyone, welcome back to my channel, Predicting the Future. Today we want to talk about a statistical method for testing whether two normal random variables are independent or not. And we are going to use a simple fact about multivariate normal random variables. If two random variables have a correlation 0, then they are independent. So that's a basic result from probability theories. And we're gonna the idea is that we're gonna test whether the covariance is 0. Use that covariance to test whether the two random variables are independent. So let's first look at the bivariate normal PDF. So this is the bivariate normal PDF where rho xy is the correlation coefficient of x and y, and the conditional PDF of y given x is this one. So it can be, you can see that this is also the conditional PDF is also a normal random variable with mean alpha minus beta x. And so you can see this is very similar to a linear function, right? So the mean is actually a linear function, which is right. So the conditional PDF of y given x is also normal with mean equals a linear function of x. And so that comes down to a linear regression problem that we just talked about in the previous video. So if we want to test whether the rho is 0 or not, we can test whether beta is 0 or not. So that becomes a linear regression problem, and it can be shown that now we don't know the rho, we don't know the standard deviation for y and x. We're gonna need to use sample variance and the sample correlation coefficient to replace those values. So here we're gonna use the sample correlation coefficient, which is Rxy hat. It can be shown that Rxy hat is actually a consistent estimator of rho xy. Therefore, and we're going to replace the standard deviation of x and y with a sample standard deviation. So it can be shown that the beta is actually it's actually the same as what we see in the linear regression problems, the point estimate of beta, the interceptor parameter. So and further, if we divide if we divide the point estimate of beta by its standard deviation, it can be shown that this becomes a t-distribution, and that becomes our foundation of testing whether rho equal to 0 or not. And so the sample deviation of beta is actually the mean squared divided by the sum of xi minus x bar squared. This is what we talked about in the previous video. You can always check back to the previous video on linear regressions to review those topics. So now it becomes we can construct a t-distribution which when we simplify this term, we are simplifying beta hat yx divided by the standard deviation, and that becomes once we simplify, it becomes this simple form, and this is a t-distribution with n minus 2 degree of freedom, and the only parameter here is the sample correlation coefficient Rxy hat, and with the type 1 error equals to alpha, then we can conclude that if the absolute value of t star is less than the t value, then we conclude that the correlation is 0, and or on the other way, if it's greater than the t value, then we can conclude that the correlation is now 0. Okay, so that's the topic I want to talk about today. I hope you like it. Please subscribe to the channel for the following new videos. Thank you.